Food chains are fundamental representations of the flow of energy and nutrients within an ecosystem, illustrating the relationships between different organisms based on who eats whom. Each food chain begins with a producer, typically a plant or other photosynthetic organism, that converts sunlight into energy through photosynthesis. This energy is then passed on to primary consumers, or herbivores, that eat the producers. Following them are secondary consumers, which are carnivores that eat the herbivores, and then tertiary consumers, which may be top predators in the ecosystem, feeding on secondary consumers. At each step of the food chain, energy is transferred from one organism to another, showing the direct feeding relationships within the ecosystem. Food chains are crucial for understanding the dynamics of ecosystems because they highlight the dependency of each organism on the next link in the chain for survival. For example, a simple food chain might show grass being eaten by a rabbit, which in turn is eaten by a fox. The fox relies on the rabbit population for food, while the rabbit depends on the availability of grass. Disruptions to any part of this chain, such as a decline in grass due to drought or overgrazing, can have ripple effects throughout the ecosystem, impacting the populations of both rabbits and foxes. The populations of prey and predators in an ecosystem are closely linked and tend to fluctuate in cycles. This cyclical nature arises because the population size of one directly influences the other. When prey populations are abundant, predators have ample food, which allows their population to increase. As the number of predators grows, they consume more prey, leading to a decline in the prey population. With fewer prey available, the predator population eventually decreases due to starvation or reduced reproductive success. This decrease in predators then allows the prey population to recover, starting the cycle anew. For example, consider a food chain involving hares and lynxes. When the hare population is high, lynxes have plenty to eat, leading to an increase in the lynx population. As more lynxes hunt the hare population begins to decline. With fewer hares available, some lynxes may starve, and their population will start to decrease. As the lynx population drops, the pressure on the hare population lessens, allowing it to recover and grow again. This cyclical pattern of rising and falling populations is a natural part of many ecosystems and is driven by the availability of resources and the predator-prey relationship. These cycles can be influenced by various factors, including changes in the environment, disease, and human activities. For instance, if a disease affects the prey species, it could lead to a sharp decline in their population, which would then cause a corresponding decline in the predator population. Alternatively, if human activities, such as hunting or habitat destruction, reduce the number of predators, prey populations might temporarily surge, leading to overgrazing or depletion of plant resources, which could have further consequences for the entire ecosystem. In essence, food chains are simplified models that depict the feeding relationships within an ecosystem, demonstrating how energy is transferred from one organism to another. They are essential for understanding the balance of ecosystems, as they show the interdependence of species. The cyclical nature of predator and prey populations reflects the delicate balance within these systems, where changes in one population inevitably affect the others. These cycles and interactions highlight the complex and dynamic nature of ecosystems, where every species plays a role in maintaining the stability and health of the environment.